Hi, my name is Jason Hine. I am the Market Segment Manager for Agrigenomics at LGC Biosearch Technologies. The genomics tools available today to researchers continue to change at breakneck speeds, and it can be tough to keep up with all the options that are available. Today, I'd like to share with you how we at LGC Biosearch Technologies approach the technology decision question with our customers in what's the best technology to apply to my particular breeding program. This diagram is a simplistic view of the breeding pipeline. Typically moving from left to right through the breeding process, different analytical techniques can and are being used regularly. Generally, it starts with characterizing a structural genetic difference and associating that difference with a particular phenotype. This work is primarily done with sequencing-based methods where sample numbers are low, but the information is really data-rich. As we move through the breeding process, the relative sample number increases and marker decreases, as well as cost decreases. The technology used for each application in general changes due to the trade-offs such as cost per sample, data, content or marker number, and the time to result. So taking whole genome sequencing and back crossing as an example, I could use whole genome sequencing to make a back cross selection, but it's very expensive compared to a PCR-based method, and it's really slow to get that data back. And so fundamentally, it wouldn't be the right tool for that job. A key question we often get asked by our customers is, what is the right technology for my particular breeding program? And that's really a great question, and one that we try to work with our customers on to find the best solution for their particular need. LGC Biosearch Technologies provides not just the products to run genotyping experiments within your own lab, but we also provide genotyping services. And so we use our own experience by running a high throughput genotyping lab to really inform our decisions about which technology to recommend. Even in our own labs, we take the approach of balancing cost of data acquisition, data or content needed for that particular project, and then the speed at which that data needs to be returned for our customer to make their selection. SNP densities at the bottom of the diagram are what we really use as general cutoff points for when we transition to a different technology. Projects less than 500 SNPs per sample are generally PCR based, mainly due to time and cost associated with generating this. Between 500 and 100,000 SNPs is where we see targeted sequencing can play, and really greater than 100,000 SNPs, or you're in the range of SNP discovery and alternative sequencing methods to answer those questions. The targeted sequencing space, that 500 to 100,000 SNP space, is very fluid in the market today. Arrays currently dominate this marker density, especially in applications where there are a large number of samples and large number of markers. However, it's important that if the sample number is really small and a universal array currently doesn't exist, targeted sequencing can still be competitive, even at that very high SNP number. If you have projects in this 500 SNPs to 100,000 SNP range, it'd actually be best to probably talk with specifically about your project needs with us and work together to identify the right tool for the job. Thank you for watching. I hope it was informative, and please feel free to reach out to us if you have any questions. Thanks.